Physics Part 51. Well, we continue with it and we find a solution for you. 4.5 meter per second. Delta x, delta t is the same as s over t. So 4.5 is equal to s over 1.5. And as s is equal to 4.5 into 1.5 is equal to 6.8 meter as before. Example number 3. A cricketer throws a ball vertically upward into the air with an initial velocity of 18.0 meters per second. How high does the ball go? How long is it before it returns to the cricketer's hands? In the first part of the problem, we want to know the distance s. We know the initial velocity is u, 18.0 ms meter per second. Upwards, the acceleration a is equal to g, 9.81 meter per second. Downwards, at the highest point, the ball is momentarily at rest, so the final velocity is v0. The equation linking s with u, v and a is v square is equal to u square plus 2as. Substituting the values, 0 is equal to 18.0 square plus 2 minus 9.81 per second. Thus, s is equal to minus 18 square divided by 2 into 9.81, which is equal to 16.5 meter. Note that here the ball has an upward velocity but the downward acceleration, and that at the highest point the velocity is 0 but the acceleration is not 0. In the second part, we want to know the time for the ball's upward flight and down flight. We know u and a and also the overall displacement of s is equal to 0, and the ball returns to the same point at which it was thrown. The equation to use is s is equal to ut plus half at square. Substituting the values, 0 is equal to 18.0 t plus 1 over t minus 9.81 t square. Doing some algebra, t into 36.0 minus 9.81 t is equal to 0. There are two solutions, t is 0 and t is 36.09 divided by 9.81, which is equal to 3.7 seconds. The t is 0 value corresponds to the time when the displacement was 0, when the ball was on the point of the leaving the cricketer's hands. The answer is required here, 3.7 seconds. Well, we have provided you this in algebraic solution. And of course, when we do solve these physics problem, we do take the help of mathematics. And this algebraic solution, in fact, has provided it. Now it's your turn. Number 1, an airliner must reach a speed of 110 meters per second to take off. If the available length of the runway is 2.4 kilometers and the aircraft accelerates uniformly from the rest at one end, what minimum acceleration must be available if it is to take off? Number 2, a speeding motorist passes a traffic police officer on a stationary motorcycle. The police officer immediately gives the chase. His uniform acceleration is 4.0 meters per second, and by the time he draws level with the motorist, he is traveling at a speed of 30 meters per second. How long does it take for the police officer to catch the car if the car continues to travel at a steady speed during the chase? What is that speed? Number 3, a cricket ball is thrown vertically upward with a speed of 15 meters per second. What is its velocity when it passes through a point 8.0 meter above the cricketer's hand?